All right, here's our next problem, another system. See if you can graph these two. We'll give you 1 minute to do it, and then we'll go over it, all right? 1 minute, go. All right, here's our next system. Y equals negative 3x and 6x plus 2y equals 4. And what do we notice about this first equation? I'll do it in red. I'll graph it in red. Y equals negative 3x. That's in slope-intercept form already. You just don't see the phantom plus 0 right there. That's not a problem, hopefully, because we've seen that before. But right away, I can see that my slope from this is just negative 3. It's a coefficient of x. But again, I'm going to show it as negative 3 over 1. So that tells me, since the 3 is negative, that would be down 3. And the 1 denominator is positive, so it would go to the right 1. And hopefully remember, when graphing these, I've always made the denominator positive, so I've only gone to the right. But it is possible for it to be negative, which means you'd go to the left. So there is our slope. And we also have the y-intercept there at 0, in this case 0, 0. So that's the b, right? 0, 0 here, which is just right at the origin. So now that I put that point at the origin, I'm going to go down 3 to the right 1, which gives us the next ordered pair. Down 3 to the right 1, that's the next one, and then down 3 to the right 1. Now it is possible, I know there's still several students that are struggling with just counting these. They know it's down 3 to the right 1, but if you're going to count lines, like some of you have chosen to do, like if you start here and then go down 3, you would start here at 0. That's 0, 1, 2, and then 3. Okay? Now some of you, and this has been good as well, some of you have been choosing to count blocks, which is good. So then you can see you count those 3 blocks. And then that would be down 3 and then to the right 1. There's the 1 block. Okay? Now that's as far as I can go down 3 to the right 1, but I can copy these stair steps going to the left. So that would be left 1 up 3, left 1 up 3, left 1 up 3. And that's as many ordered pairs as I can fit on this graph. Now I'll draw the line just so you can see that you can if you choose to. Doesn't matter if you do it after like I did before, or before like I'm doing right now. So that is the graph for the equation y equals negative 3x or y equals negative 3x plus 0. Let's do the next equation again. I'll do it in purple. 6x plus 2y equals 4. I need to change this in a slope-intercept form. So 6x plus 2y equals 4. Again, we can do this in 2 steps by zeroing out the x's. So that's minus 6x on this one. To zero that out, drop your 2y equals, again, these two terms are not like terms to combine, the negative 6x and positive 4. And then divide all the terms by the coefficient of y, in this case 2. So that's a phantom 1 now. Y equals negative 6 divided by 2 is negative 3. So negative 3x, and 4 divided by 2 is positive 2. So I can see then that my slope, the coefficient of x, is negative 3. I'll make that negative 3 over 1. Which also tells us the rise and run. Since it's negative 3, that's down 3. And positive 1 is to the right 1. Down 3 to the right 1 from where? That's where we need the y-intercept, b, which is at 0, 2 in this case. Okay, that's that plus 2 right there. So I'm going to put 0, 2 first on the graph. There in purple. And then I'm going to put all the other ordered pairs on the graph using the slope. So I'm going to go down 3 to the right 1. It's this next ordered pair. Down 3 to the right 1. Here. Down 3 to the right 1. And I can fit one more right there. But I can go the other direction. So that'd be left 1 up 3. Left 1 up 3. That's as many points as I can fit. So let's go ahead and put this graph, this line on the graph. That looks pretty good. Now just from the 2 lines we've graphed, we can see that there's no intersection between these 2 lines. In fact, we'll never see one. If we remember, slope indicates the steepness of the line, and for the red equation, we had a slope of -3/1. The purple equation, we had a slope, the same slope, -3/1. So the steepness is the same, and in addition to that, they're going through the y-axis at different points, 0, 0, and then 0, 2, which means these two lines are actually parallel. And when you get two parallel lines, remember, just from the objective, that the solution to a system of equations is where the two lines will intersect. Well, when will parallel lines intersect? They never will. So this one just has no solutions. There is no solution to this system because the two lines are parallel. So when you see the slope is the same between two lines, and the y-intercepts are different, those two lines are going to be parallel. Now, is it possible to have two lines that are the same line? Yeah, we'll see that example coming up.